All right, so we are starting our new unit over relations and functions. As we go through here, you can pause it to finish writing something. If I have not given you enough time, you can fast forward, you can rewind it, but we're gonna go through here and you need to write down everything that I have. When you get done, you're gonna show this to Ms. Herman and then she's going to give you the homework for you to work on. So our whole goal today is to determine if something can be considered to be a function. If it's not a function, it's going to be a relation. So the first thing we need to do is define our relations. So relations, I'm just going to put it all up here so I can talk about it. A relation is pairs inputs with outputs. Inputs are also referring to your x values. Outputs refer to your y values. And when we see it as a list of ordered pairs. So for example, remember that when we say our ordered pair, we're always talking about our x and then our y. The x coordinates are known as our inputs or our domain values. All of those words are synonyms. They're interchangeable. Same thing for the y coordinate. We have outputs and range values. Always talking about the same thing there. Then when we talk about our functions, that's a specific type of relation. And that is a specific type of a relation, and that's where we have exactly one output with every input. So every input has exactly one output. And we can show that as an equation. We can show it as input-output tables. So those are just the tables that you're used to seeing. X values, Y values, because remember, input still talks about X, output talks about Y. We can show it in words, we can show it in graphs, we can show it as sets of ordered pairs, but the main thing here that you need to remember is that x values have to be different. The y values can be the same. So let's take a look at some and see if we can determine. If we're going to represent this as how would this be represented as a function below? We can describe this in two different ways. We can say that we can say that we have our inputs. We can say our inputs, and we can talk about all of these. This is a coordinate plane, so this is 1, 2, 3, 4. So we can talk about all of our inputs. Those are the x values. So inputs, we have 0, 1, 2, 3, 4. And our outputs, those are all of our y values, are taken from our y-axis. And that we have 0, 1, 2, 3, 4, 5, 6, 7, 8. So our actual outputs here, we have 0, we have 2, we have 4, we have 6, we have 8. So those are a way to show that as inputs and outputs. I could also put that as a table. So I have 0 and that matches with 0. I have 1 and that matches with 2. I could go 2, that matches with 4, and I can kind of continue that on from there. So I can do it as ordered pairs too, which would be 0, 0. I have 1, 2. I could do 2, 4, 3, 6, 4, 8. So all I'm doing is looking at my graph over here and pulling out all of that different information, looking at the inputs or the outputs, the x coordinates, the y coordinates, and trying to figure out which one matches with what. And this is actually representing a function, because if I'm looking at this, every input or every x value has exactly one output. 0 has an output of 0, 1 has an output of 2, 2 has an output of 4, 3 has an output of 6, and 4 has an output of 8. Everything here in my x values, they do not repeat. So this is considered a function. Let's take a look at another one here. When we're trying to identify it, remember that for a relation to be a function, every x value or domain has to be paired with one and only one range value or y value. So as I'm looking at this, and again, domain meaning x value, range meaning y value. So I am really focusing in on all of my x's, and I'm trying to see if something repeats. So as I'm looking at this, I notice that one repeats here and one repeats here. So I'm going to take a look at their outputs. I have an output of 2 and an output of 3. Because that is not the same, this is going to be considered a function, or it's going to be considered a relation, because my input of 1 repeats and has an output of 2 different answers. So 1 cannot be 2 and 3 at the same time. Looking at this next one, I have an x value of -2, an x value of -1, and 0, and 1, and 2. Because there is no input values or domain or x values that repeat, this is considered a function. Looking at this next one, I have -2, -1, -1, 0, 1, and 2. So I'm looking to see for any repeats here. Well, I notice I have a -1 and a -1. I've got an output of 0 and an output of 1. Those are 2 different things. So because I have an input of -1, have 2 different outputs, that makes this a relation. Let's look at another one. Now we're given our actual tables here. So again, I'm still looking at my x values or all of my inputs, and I'm trying to figure out if any of these repeat. This has 0, 1, 2, 3, 4. There is no repeating number, even though my y values do repeat. I'm only looking at my x values. So because my x values don't repeat, this is considered a function. Take a look at our next example. Here I have an input of 8 and 8 and 8 and 8 and 8. All of that is the same number, and if I look, my outputs are all different. So this is going to be considered a relation because every input does not have exactly one output. Looking at this is our mapping diagram here, and you're going to follow the arrows. So really we're talking about 1 goes to 8, an input of 2 has an output of 9, an input of 3 has an output of 10 and 11. So because 3 has an output of 10 and an output of 11, this is a relation. These get a little bit tricky, but they're not too bad. We can look at this. So each radio frequency X in a listening area has exactly one radio station. So if we're going to talk about St. Louis, does everybody, when they turn on their radio, when we turn on 93.6 or 105.7 or 94.7, does it all have the same radio station? If so, then yes, this is considered to be a function. So this is a function. If we talk about the same TV station, X can be found on more than one channel. So if I'm going to turn on my TV, can I find KMOV on every single channel or on more than one channel? No, I can only find it on one. So this is going to be a relation. It is not considered a function. When we're looking at this, we're saying X equals 2. So that means if I were to put this as ordered pairs, every X value here is going to be a 2. So when I say X is 2, I don't mean that it has an output of the same number here. I'm just saying in this example, X is 2. So because this repeats, this is a relation. Looking at this next one, if I were to put in an input here for X, let's say we put in an input of 0, I would end up with 2 times 0 plus 3. Well, 2 times 0 is 0 plus 3, and I end up with an output of 3. So here I have an input of 0 and an output of 3. If I were to change this and make this an input of 1, I get 2 times 1, which is 2, plus 3, and I get 5. So an input of 1, and I end up with 5. Am I getting a different one every time? I'm not getting a different answer every time. When I put in a input for this, I'm getting one output. So this is considered to be a function. If I were to draw this on a graph, it would actually be a line. All right, here we go. So identifying it from a graph. If a relation is a function, then any vertical line passing through at least most one point on the graph. If you find a vertical line that passes through 2 points on the graph, then it is a relation. That means it has 2 different outputs. So let's take a look at this. This is called the vertical line test. So I have all of my graphs here, and I'm trying to determine if it's going to be a function. If I were to draw vertical lines going on this first graph, I am only intersecting between one spot on this line, here and here. and here. It's not twice, so this is considered to be a function. Looking at this next one, if I were to draw lines on here, I'm sorry, my lines are always the straightest, but if I were to draw lines on here, would I end up with the same thing? Yes, I'm crossing on that same line. So this is considered, because it's got this inner curve going in, this is considered to be a relation because I run into two different points. Looking here, if I draw my lines all the way through here, I am not running into another point. This is considered to be a function. My vertical line, it passes the vertical line test. Looking over here, I have ordered pairs or just points on here. If I draw my vertical line here and here and here and here, this line right here does not pass because it's going through this point and it's going through this point. So because it's going through these 2 points, this is going to make this a relation. And this one, if we draw our vertical line test, or our vertical lines, it's passing through more than 1 point. So this is considered to be a relation. When I look at this next one, we're still talking about ordered pairs, but if I draw my vertical lines going through that, I'm not intersecting between more than 1 point. So this is considered to be a function. All right, when we talk about domain, what's another word for domain? Domain talks about our x values or our input values. Our range talks about our y values or our output values. So again, all of those words are interchangeable. So when we're talking about something like this, we're just going to, these are 2 different examples. So our first example is given to us as ordered pairs. So I'm going to take these ordered pairs and I'm just going to write out. The domain talks about the x values, so I'm just going to put this in order. We're talking about -2, -1, 0, 1, 2. Those are all of those x values. When I list out my range, I'm going to say the range values. So that is 5, 8, 6. And because 6 is written twice, I don't really need to include it twice. Could you? Sure, but you don't need to. And then I have my 7. So those are talking about all of those. So if we're going to talk about this next one, this one is a graph and it's actually connected and it's kind of going through a couple different points here. So I'm going to show you, we're going to do wall to wall and floor to ceiling. So if I'm going to look at this, I'm going to draw as if I were going to make a wall. And that's talking about or crossing through the x value. So that's talking about my domain. So what is the smallest and the largest x values that we're going through? Well, if I look all the way over here, I'm going this is going all the way over here to -9. And this is going all the way over here to +8. So when I show this, I'm going to say that -9 is less than or equal to x, which is less than or equal to 8. So this is just showing the inequality. This shows me that the range of values for x can go from -9 all the way up to 8. And because those are closed circles, that's why I'm going to use that less than or equal to. When we talk about the range, we're going to look at the floor to the ceiling. So if I draw the floor and then I'm going to draw the ceiling and I'm going to count, we're talking about going through that y-axis, so we're talking about my y values. I'm trying to see what is the smallest or the lowest y value. Well, that's down here, and that is at 1, 2, 3, 4, 5, 6, 7, 8. That is at -8, and the highest that this is going is up at 3. So really, we're talking about these points to here. So the smallest value that I'm going from is -8, which is less than or equal to y, which is less than or equal to 3. So again, I'm talking about the smallest range or the smallest y value is -8, and I can go all the way through to having 3, which is the highest my y value can go. All right, when we look at this one, independent and dependent variables, you guys have talked about this with science, but just understand that when we talk about input, domain, x values, those are all talking about our independent variables. And when we talk about our output, our range, those are talking about our dependent variables. So again, you've got a lot of synonyms there. So when I'm looking at this, we can use equations to represent functions by determining the dependent variable, remember that's our y value, and in terms of our independent variable, remember that is our x value. So let's take a look at one. Oh, well, there's your equation. That should look